Hello guys, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for sparing time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. This is our channel name, Mathematical Side Trips. I am Napoleon A. Gaking Jr., a math teacher. In this video, construction or discussion will focus on construction of simplification expressions involving irrational numbers, starting with the answer. So here we will try to construct irrational numbers of the form square root of x plus or minus y square root of q and square root of x plus or minus y square root of z plus or minus x minus plus y square root of z. Problems of this type have appeared in many mathematical competitions. Okay, first the expression square root of x plus or minus y square root of q. Simplification problems of the form given above have appeared in many mathematical competitions. A brief discussion of this type of problem regarding its simplification and construction will be given here. Now, since the square of a plus or minus b times the square root of q can be written as x plus or minus y times the square root of q, then the square of numbers of the form a plus or minus b times the square root of q are of the same form. Here we will describe the number b squared q as a square multiple of q. So this is true. The square root of a plus or minus b square root of q is equal to x plus or minus y square root of q if x and y are integers satisfying the following two conditions. A is equal to x squared plus y squared times q, and b, number 2, b is equal to 2 times x times y. So we have that equality or identity. Example, simplify the following. So we have these 4 problems, simplification problems. Letter A, square root of 59 plus 30 square root of 2. Letter B, square root of 97 minus 56 times 3, and so on. C and D, we have C and D. Okay, for letter A, so we think of numbers smaller than 59, a perfect square smaller than 59, because we have to split 59 as the sum of a perfect square and a square multiple of 2. So perfect squares smaller than 59 are 1, 4, 9, 16, 25, 36, and 49. And among these choices, we have 9. And then the remaining number is 50. And so we check if 50 is a square multiple of 2. And it's correct, because 50 is 25 times 2, and 25 is a perfect square. So therefore, the square root, the number 2 times 9 plus 50 plus 30 square root of 2 is actually the square of 3 plus 5 square root of 2. Therefore, the square root of 59 plus 30 square root of 2 is equal to 3 plus 5 square root of 2. In letter B, again, think of a number, a perfect square smaller than 97, and the other one should be a square multiple of 3. So in this case, we have 49 and 48, 49 being a perfect square, and 48 is equal to 16 times 3. 16 is a square number, and 3 is the second radicand. So this number, square root of 97 minus 56 times the square root of 3 is equal to 7 minus 4 square root of 3. Letter C and D are similarly solved. However, in letter C, take note that instead of the final answer 4 minus 2 square root of 5, we use 2 square root of 5 minus 4. It is because we always take the positive root of a number, and 4 minus 2 square root of 5 is a negative number. So since x and y must satisfy certain conditions, not all numbers of the form square root of a plus or minus b square root of q can be simplified to the form x plus or minus y times q. To see this, let's look at the number square root of 60 plus 30 times the square root of 2. So we think of square numbers smaller than 60, 1, 4, 9, 16, 25, 36, and 49. And think of the other number, which should be a square multiple of 2, and there is none. There are no numbers or integers x and y exist such that x squared plus 2y squared equals 60 and 2xy equals 30. Okay, I mentioned this earlier. In the third problem, we use 2 square root of 5 minus 4 rather than 4 minus 2 square root of 5. Now, the fact that the square of a number of the form a plus or minus b square root of z is always of the same form makes the construction easier. Thus, to construct problems of the form square root of x plus or minus y square root of z, just square any number of the form a plus or minus b square root of z and put it inside the square root symbol. Another type of irrationals whose squares are of the form x plus or minus y square root of z are the irrationals of the form a plus or minus b times the square root of p times q, where p and q are prime numbers. If there are integers x and y such that a is equal to px squared plus qy squared, so a square multiple of p and a square multiple of q, and b is equal to 2 times x times y, then the square root of a plus or minus b square root of pq can be written as x times the square root of p plus or minus y times the square root of u. Example, simplify 57, square root of 57 plus 12 times the square root of 15. So here we think of a square multiple, since 15 is 3 times 5, so we think of 57 as the sum of a square multiple of 3 and a square multiple of 5. So in this case, 12 plus 45 satisfy that condition, because 12 is 4 times 3, and 4 is a perfect square, and 45 is 9 times 5, and 9 is a perfect square. So we have this number. 57 plus 12 square root of 15 is actually the square of 2 times square root of 3 plus 3 square root of 5. Therefore, the given number square root of 57 plus 12 square root of 15 is equal to 2 times the square root of 3 plus the 3 times the square root of 5. Now, expressions of the form square root of x plus or minus y times the square root of z plus or minus the square root of x minus plus y times the square root of z. This is an enhancement of the preceding form. However, since the two radicands are conjugate irrational numbers, the manner of simplifying this number is obvious. Consider the following example. So the two radicands inside the outer square root signs are just conjugates of each other. So whatever you do to the first one, just do it with the second one, except for the signs, because they have opposite signs. The first one is plus, the second one is minus. Same thing with the letter B. However, we also have another way of solving these problems. So the first one is by squaring the number itself. So we have x squared equals this square of these numbers, and then simplifying it, we have 180, and 180 is 36 times 5, so therefore taking the square root of both sides, we have x, which is the original number, is equal to 6 times the square root of 5. Another solution, the solution suggested in the preceding discussion, we have this, okay? So we think of 49 as the sum of a square and a square multiple of 5. So we do that here. Therefore, the first one is equal to 2 plus 3 square root of 5. The second one is 3 times the square root of 5 minus 2. And so, again, we use 3 times the square root of 5 minus 2 instead of 2 minus 3 square root of 5, since 2 minus 3 square root of 5 is negative. So therefore, adding these two results, we have 6 times the square root of 5, which confirms our first result. From what we have seen, construction of this type of problem is just a matter of assigning integer values to a, b, and z in the expression, okay, that expression. So that is all for now. We hope that you have learned something new, interesting, or useful. The next video is about other forms of irrational numbers. God bless.